of this polynomial function. Now, but I just stop there and say find the zeros, and I do not specify which ones to find. What do you think they're asking for? Find all of them. Now, if they want you to find just the real, they'll phrase it as find the real zeros. Or sometimes they'll find the, and sometimes they'll use the word complex, okay? Which means also find all. So you guys are trying to find all of these, and I don't think, but remind me, I don't think we've worked this one out yet. And I saw it, and I thought, we gotta look at this. Okay, here goes. P of x is equal to, Jonathan, look at it carefully. See, I don't think we've worked this one. Is equal to this. 3x to the fourth plus 5x cubed plus 25x squared plus 45x subtract 18. Step back and look at it, make sure everything's copied down correctly. Hope so, it doesn't throw us off. I think that's copied down correctly.
Yep.
Gee, was that on the handout?
Yep.
It was. Now, I have not had a chance to work it yet. Have I?
I don't know if you did this.
No, okay. Guys, how many zeros am I expecting?
4.
No, so I gotta get 4. So next Wednesday, if you have one of these, and by the way, next Wednesday also will be just one problem. Especially on a topic like this. You'll have one problem, it'll take you a good 30 minutes to work out one of these problems to find the 4 zeros. So guys, to find the 4 zeros, that seems a good way to start. And you want to go through Descartes' rule and see how many of the 4 will be positive.
Check for the sign change of only one.
Exactly. Okay, so in Descartes' rule, here we go. Rule of signs. I think Eric said he's already checked. There's no sign change here. From one term to the next, no sign change. No sign change. Finally, one sign change. So that tells me to expect of the 4, 1 positive real 0. Okay? Now, the number of negative real zeros to expect here. The routine is, now go back to your function and express p of a negative x. So if you replace all those x's with a negative x, guys, I'll do it fairly quickly and see what happens here. The first term will stay like it is. The second term, because of the odd, x cubed, is going to change. Change signs. Next one will stay the same. With the x squared. This is going to change. And of course, we've got minus 18 on the end. Guys, the sign changes here. From the first term to the second term, there's a sign change. From the second to the third, sign change. Third to the fourth, sign change. And of course, there is no sign change on the end. So there I have 3. So in terms of negative real zeros, that tells me to expect 3 of the 4 to be negative. Or, what does Descartes say to do, just in case? Subtract by 2, which leaves me what? That might be only 1 negative real 0. Wipe that off. Now, here we go. Guys, it's 1 positive for sure. So you might want to search for that 1 positive when you start searching for the answers and try to find it first. Now, in combinations, if 1 is positive and 3 negative, then that takes care of the 4. 1 positive, 3 negative. If 1 is positive and only 1 is negative, I'm supposed to get 4 zeros. 1 positive and 1 negative, that's another combination. That would leave the other 2 to be imaginary. That can happen. Okay, so let's see what's going to happen here, guys. Now, in the attempt to find the zeros, that's where the problem is. I don't think we're going to have any trouble with this. Descartes' rule. Someone suggests to me, what would you try next?
P over Q.
Okay, I need to list P over Q. It's called the rational zeros theorem. Right here. This might be the last example I use for this particular topic. So watch carefully. rational zeros theorem. Most students recall it as P over Q. And by the way, I should always emphasize that word rational. It will give me only rational possibilities. So if, when I solve this, and of those 4 zeros I'm expecting, some, I don't have them yet. Some may have a square root in them. A square root 2 may show up as one of the answers. And I cannot, it will be an answer, of course, but I would not be able to find it here. This is only for rational, not irrational. Okay, P over Q, the P should be, like the kid back in middle school I was telling you about, I need to list all the factors of my constant term on the end. That's what the P is. And guys, there's quite a few numbers multiplied together to give you a negative 18. I'm gonna write mine like this, if you don't mind. Plus minus 1, plus minus 18, plus minus 2, plus minus 9, plus minus 3, plus minus 6. Am I leaving anything out for 18? That takes care of that. The Q represents all the factors of the leading coefficient. We're back here. So we'll list all the factors of 3 that goes on the bottom there. And guys, when I do that, we end up with thinking it's not too many. Plus minus 1, plus minus 3, I'll write mine like that, for factors of 3. Now here's the issue. Usually I don't ask you to list all the possibilities. That's gonna take a little time here. Look at all the possibilities of zeros here. It could be, you say, Professor, it could be on top here, 1 over 1. Could be an answer. Could be 1 over negative 1. There's 2 possibilities. Jump over here, it could be 18 over 1. Could be 18 over negative 1. I haven't tested yet. Down here, 2 over 1. 2 over negative 1. 18 over 3. 18 over negative 3. 2 over 3. 2 over negative 3. 9 over 1. 9 over negative 1. 9 over 3. 9 over negative 3. If you start listing all the possibilities, there's quite a few. You understand all those different combinations? I don't know why I list all of them, but there's quite a few of them. Now we have to search and find one that is a 0. In other words, is an answer. The sad thing is, if I would do this to you, which I wouldn't, if I gave you one where there are no real zeros, they're all imaginary complex, then you sit there for half an hour, and I'm sitting like this smiling. Because you're going to test and test and test, and you're going to start crying, get frustrated, and all that business, and you say, oh my, I'm going to fail this. Because I gave you one that has none. You have all those possibilities, you start doing the synthetic, it doesn't work. Here, though, I would not do that to you. There's some out there that would do that, though. There are some answers here. So we'll be able to find the 4 we're looking for. Now, guys, Leo, I know when yesterday, for some reason, he gave me of all these different combinations, one to work. And I tested my synthetic, it worked, and it took me right to where I wanted to go. All students are not like that. You may, and I wasn't like that. My friend may find one in a classroom, and all of a sudden they find it to work just like that, and they're out of here. And then you're still searching for one to work. And finally, you don't find the one that did work to get you started to find the other 3. You don't find that one until the end of class. And Randy says, I'm collecting papers. Right when you found the one to work, and all the students found it. That can happen. It's very frustrating. Okay, I'm gonna give you a few little clues, but first, does anyone have one that you'd like to test? And I'll do it not by direct. Substitution don't take forever. I'm gonna do it by synthetic. 3 again. You sure? I didn't do this yesterday, did I?
No. We did it in
Okay, so I'm gonna do it by synthetic. Oh, synthetic substitution. Okay, just come to test 3, guys. Test like this. Put on the outside there. Now go back and pick up my coefficients and constant of the black function. So I've got a 3, I've got a 5, 25, I'm looking back to make sure, 45, and a negative 18. zero on the end. Can anyone tell me before I jump in, suppose you look back at the black function and it starts out with 3x to the fourth like mine does, but 5x cubed was not there. It jumps down to 25x squared. The 5x cubed for some reason was left out. What might you have to do in this synthetic to account for, they left one of the terms out?
Put a zero.
You have to put a zero in there. To act as a placeholder in case something's missing. Here, everything's there that we need. Leo, here goes. 0, 3, 9. It's not looking good already. Is that 14 at this point? Because I think next I'll get 42. And then on the month, I think we get 67. Ooh. And 3 times 67, something even bigger. I don't think so it'll work. So sometimes you'll recognize, it's not gonna work. I see those numbers are just not going to work. Leo, let's try something else. Does anyone have
-2.
-2? And I say if -2 is a possibility, right here it is. -2 over 1. That's a possibility. So that's -2, guys. -2 blocked off. This. And we'll do with the -2. 0, 3, -6, -1, 2, 27, -54, -9. I did this so quickly. I think, Eric, if I made no mistake, it works. Did anyone else get that same number? Did it work? I did it quickly. Did it work, guys? Okay. Now, that takes me down to, I have 3 remaining zeros to discover. I got one of them. Now, I would suggest you may go back to the very beginning, up here, and test for additional zeros. What I like to do though, after you find one to work, I like to stack these up and say, no, to save me a little time, I just want to test to find the next one just on those remaining numbers. After I find one to work. Now, does anyone have a favorite number of the remaining possibilities that may work?
-1 over 1.
-1. I'm going to try -1. -1 here. Okay, 0, 3, -3, -4. That's what is that? 4? Not going to work. I see ahead of time it's not going to work. Let's see if you guys agree with me. Because I see a 31 coming out. I don't think there's any way possible to get a 0 to come out on the end. Eric, that's the problem with these. Leo, what do you think?
-3?
Okay, let's try -3. 0, 3, -9, -10. Watch my work here. Oh, no, it's not gonna work. If I did make a mistake, and I watch my arithmetic here. Do we see ahead of time it's not gonna work? Okay, so that's out. And you're taking the quiz and the frustration is rising. That's why I brought this one in. I had it on the handout. Frustration is rising. You say, I'm gonna walk out of here and just have one of the 4 zeros, and Randy's just gonna fail me on that quiz. What am I gonna do? And his spring class is full. You can't take any more students. What am I gonna do? Does anyone have another one? Oh, there you go, here we go.
I think 3 works out.
I thought we tried 3 earlier.
Yeah, but you can do it wrong.
Can it be -2/3?
-2/3? Okay, -2/3. Vanessa, let's see, -2/3, guys, that's not a possibility, of course, that's -2, she says, Professor, put it over 3. That's what P over Q means, put the P over the Q. So -2 over 3, she says -2/3. Look at this, we'll try it. Here we go, 0, 3, now be careful, fractions. We multiply these two together, guys, will the 3's cancel? It leaves me a what, -2? I got a -3. Now if I multiply these two together, anyone tell me a -2/3 times a -3? Sort of canceling again, so what am I going to end up with this time?
6 over 3?
which is positive two? Is it gonna be a positive two? Positive two. Vanessa? No. And Anna? Hart? We're testing negative 2/3, I put a 3 there, multiply these together, get negative 2, add them up, get negative 3. Multiply these two together, I can see the 3's again cancel, positive 2, I get 29. And I'm afraid if I try now with that with the 29, it's gonna give you something awkward. But I thought it was a good guess. I don't think it's gonna work.
What about positive 2 over 3?
Okay, well, did you say negative 2/3 or positive 2/3?
She said negative.
Negative, let's try positive. Okay, 3, here we go back. That's when she gave me that 2/3, I thought, whoa, that might work. Okay, 3, 2/3 times 3, 3's cancel gives you a 2. Darn it gets worse. Gets worse. So my next possibility would be 2/3 times 1, you're not gonna put a fraction there. You put in 2/3 here. This should be nice whole numbers, integers. Leo, what do you think?
I'm sorry, I'm gonna double down, I generally think it's 3 now, like.
You must, wait a minute, Leo's saying, Professor, come on. He thinks after that 3, looks like it might be 3, I think so, let's try 3. 0, 3, 9, 8, 24. It's not gonna work.
My son.
What about negative 6?
See, we're getting desperate. Oh, by the way, is negative, negative 6 may work, but is negative 6 a possibility? Certainly is. Negative 6 over 1. Negative 6. I'm doing this on purpose, guys. Negative 6. Here goes. 0, 3. Negative 18, not looking good. So negative 19, I don't even want to multiply 16 times 19. That's gonna be a big number there. I don't think that will work. It will lead me to a 0 on the end. Numbers looking awkward. My goodness, all of a sudden, Jonathan, remind us, how many zeros were there before? We found in a half an hour 1. And you got a job at NASA. That's a big fire. Jeez. Mama.
Are the numbers small enough now that we can just plug them back
She
in?
said, wait, Professor. I can do additional testing. And I will tell you ahead of time, I think there is one more among that P over Q that will work. We just have not discovered it yet. Leo wants to test 3, 3, 3, 3, 3, and it's not working, okay? But now Mana's been clever. She said, Professor, you showed us something yesterday. She said, sometimes you told me I could just stop after I test one and write down what those remaining numbers mean at this point, and it might help me to find the remaining zeros. Guys, by the way, we started out with a degree of 4. After you discover one of the zeros, which we have, then this should drop down to a cubic. Will those numbers represent coefficients of a cubic?
Yeah.
I've already found 1, so it drops down to now a cubic. There's 3 remaining zeros. So this might say all of these numbers represent this, Professor, if it'll help you. Anna, help us. And then, if we're clever and not want to do additional testing, we will now group. I love grouping when it works. And that first grouping, take out a common factor of what, x squared?
Yeah.
And 3x minus 1 left over. Down here, take out a common factor of 9. 3x minus 1 left over again. And therefore now I have a 3x minus 1 to be taken out as a common factor. I know it shows up twice, but you're just taking it out as a common factor, leaving x squared plus 9 when you take it out. Mom, you help us. It worked here. I do not have to do additional testing of numbers because it's getting frustrating. At this point though, if I set this equal to 0, look at this. If you set this factor equal to 0, guys, and solve it, quickly you're going to end up with 1/3. Hang on. was sure enough 1/3 a possibility back here that no one told me to test. 1/3. 1/3 was a possibility. Leo was all focused on the 3, but not the 1. 1/3. If someone had said, Ramsey, check 1/3, it would have checked by synthetic. But we found another way here. The guys got 1/3. This right here will lead me into, when I solve it, let's move the 9 over.
3i.
There you go.
Plus or minus 3i.
Plus minus square root of -9, which will give you a 3i. Now do I have all 4? Am I finished? We have all 4 zeros. Jonathan, Descartes told me earlier, when I finish up, and I'm finished, we have right now -2 that we guessed and found early on. We got 1/3 now. We have 2i, 3i, and a -3i. We have 4. Now back here, I ended up with, let's see, what did I end up with here, guys? Did I end up with 1 positive? Yeah, right here it is. From Descartes, 1 positive, positive 1/3. I ended up with 1 negative. Right there. And did I end up with 2 imaginaries left over? And there's 1 zero. And Mona walked out of the room early. You guys see her walk out and said, oh, she must be smart. You know, those students who walk out early, I've been in those classes who were on the last one to leave. Yeah, well, I said, boy, they must be smart. They left in 5 minutes. They found out later on, some of them weren't smart. They were just dropping the class. Gee, they weren't smart. I could like, whoa, I'm the last student here. We got it. We got the 4. Okay. Now, you're talking about frustration? If Mona had not noticed this for us, or if it had been some way that you could not have done what she suggested, then you would have to keep searching here. And finally, now watch, I'm gonna race a little bit here and take questions. She helped us out. If someone had said, Ramsey, test 1/3. We didn't do it, but let's test 1/3. By synthetic. 0, 3, guys, 1/3 of 3 is what? 1, 0. 1/3 times 0 is 0, 27. 1/3 of 27, 27 divided by 3 is 9, works. So it eventually would have worked. But she helped us. I saw some hands going up before I asked one more question. Yeah.
So, can I answer my question, but for the part where it says 1/3, that would be 3, what is it? That would be 3x minus 27. If you were to take it and put it into the equation.
Oh, he's just saying on the.
Oh, you mean put it in factored form?
Yeah.
Okay, I got you. In fact, we're going to do it right now. We're going to do it right now. Guys, let's go back to the black. Now, since you have the answers, now I'm going to use a different color here. I'm going to use green. Can someone tell me in green? Now, how would this function look? The black. How would it look in factored form?
X plus 2.
X plus 2.
And
Got 2.
I guess you would do 3x minus 1.
I love that. That's what,
And then it would just.
David, that's what you were talking about. That picks up 1/3. And then I have those imaginaries to worry about, which came from somewhere down here. I gotta be careful with the throw. Guys, where was it down here? I got it somewhere. Oh, up here.
Would you do x minus 3i, x plus? Or
Ah,
would you
beautiful.
do x squared plus 9?
Wow. I would do, look at this. This, like you said, and leave the eyes in there. Now, if though, I say don't leave the eyes. But you still have to express something on the end to take care of the zeros. Anyone tell me if I say don't leave the eyes, how else could you express on the end here? Which I like those right there. What's another way to express on the end to make sure you get the answers?
X squared plus 9.
X squared plus 9. We'll take care of it. That'll give you plus and minus 3i. Okay. Makes sense? here we go. But this is a lengthy problem. I see some students looking, thinking, oh, Professor, can I do one of these next Wednesday? I don't know, Professor. But I know you're gonna give me one with 10 terms in it. And I'm going to go through and search 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 for an answer. Any concern after this? After we've done this? Now, you know what I'm asking you to do, and we're gonna do one tonight at the quiz. Now let's graph this. I'd like to know what this graph looks like. Now this polynomial function. Who on earth would think someone would be asking to graph that black function? I want to see this picture. What does it look like? Based on what we have up here, let's see what it does look like. And this takes into consideration end behavior, x-intercepts, touch, cross, and all that business. I'm going to get a rough sketch here. Here we go. Let's pick up the x-intercept. What are my x-intercepts?
-2 and 1 over 2.
Only -2 and 1/3, not the imaginary. So I got -2 to mark it here. -2, and I heard 1/3, put 0 in there. Put a 1 for a reference. Guys, we'll squeeze 1/3 in right there and label it.
And then you can also have both the x-intercepts, you can have both of them coming in from positive infinity. If that
Yeah, let's get, hold on. Absolutely. Is there a y-intercept? If you go back to the original black, replace all those x's by 0, find p of 0, get -18, so it's way down here. That's what you're going to be doing tonight on the quiz. Look at my x-intercept and y-intercept. In behavior, oh my goodness, here we go. Limit as x gets large. I'd like to know what p of x is doing. And all you have to do is go back to the first term. It all is determined by this. So if I take a look at 3x to the 4th, that's sort of like a parent graph. And guys, if you replace x by some positive infinity, some positive large number, like 50, 100, raise it to the 4th, it really gets big. Times 3 still remains big. Answer? Infinity. If you try it on the other end, or end behavior written like this, you're approaching negative infinity of this function. Then you go back up there, replace x by a negative number, raise it to the 4th, which turns it into a positive, times the 3 out front. Result? Positive infinity again. And Leo, you were asking about, Ramsey, could you show me x cubed, x to the 4th, x to the 5th? That's what this comes down to. That's my end behavior. Guys, got the zeros, I got the x-intercept, the touch cross will do. Let me jump on this and get the end behavior done first, since I have it in front of me. Guys, out on the, on both ends, is it rising? Is it going through infinity? So I can go out to this end on my graph and say, Professor, it's got to be doing something like this. Now here on this end, it's got to be doing something like this. That's the end behavior. And put a little curve to it. Now you can take into consideration the cross touch and get a pretty good graph here. Guys, the cross touch, let me go back to -2. And if you want to look at -2 in the green, came from x plus 2 factors raised to, there should be a 1 there. Since it's odd, it's going to cross. 1/3 came from, there gave me 3x minus 1. On the outside of that green, there should be a 1 for an exponent. Odd, so it's going to cross again. And of course, my imaginaries are not on there. Don't worry about those. So that tells me at -2, what am I going to do, guys? I'm supposed to cross over. As I do cross over, what must I pick up eventually? That -18. Now, let me make sure it looks decent. Erase this right here and make it look like it might. Who knows what it may do, Anna? It may do this, go down to a -2, come down. Who knows? It may come back up and pick up that. Right? And it's going to continue up, and it's going to join So it's gonna pick this up. And guys, at 1/3, we said it's gonna do what, cross again? Cross the x-axis?
Yeah.
So it's gonna take some shape like that. I didn't draw it to scale, I didn't plot additional points, that's just a rough sketch. Looks much like a what? That's not. The parabola's for what, x squared? And the reason it does sort of take that shape is, x to the fourth is x squared squared. That would give you x to the fourth. You guys agree? That's a basic shape of the graph, yes.
So I have a question, like, when you went all the way down to -18, and you brought it back up.
I don't
You
know
were
what,
just guessing, right?
I was guessing.
But if I just.
It may go directly to -18.
Oh, so if I just went like down and went through -18 a little bit higher, but same
I'd
kind
have
of.
to give you credit.
Okay, cause this is.
I'd have to give you credit, unless, on the quiz, I say, find f of -1, or in this case, p. Find p of a -1, plot me an additional point.
Okay,
Um,
so it's firm.
Park, or Andy, either one of you guys. Could you quickly find what p of, this is good. On this black function here, could you quickly replace all the x's by -1, or in the factor form, it's up to you. By -1 and see what the result is, if I go back and replace all the x's by -1. Find p of a -1. Which would not be even hard for us to do without a calculator.
60?
Is it 50?
60?
You got 60,
Yeah.
it's 60.
-1?
Yeah, -1, it's 60.
Yeah.
Okay, if it is, look at this, at -1, it's way down here.
Now we'll go.
It will go, whoa, down here, then eventually start climbing back up.
Got it.
But I would not know that unless I did, -1. Okay, so tonight, I'm gonna ask you to do that, I don't think I asked you to plot additional points to refine the graph.
Okay.
Yeah,
So honestly, with the end behavior thing, we don't even need to memorize parent graphs, we can just do the limits.
gotcha, absolutely, but you tell me though, before I close this down. Does anyone think they know what the x to the fourth, which is what it pertains to, the x to the fourth graph, just x to the fourth? You can plot points, do a table or whatever, what do you think an x to the fourth graph looks like?
It is pretty much identical to an x squared parabola, but the vertex is more square.
Okay, so you're telling me if I plot points here, it may look somewhat like a parabola.
Yeah.
But you're telling me maybe, Professor, it may be more stretched out, maybe. I should go up there, through here. Is it like that? In fact, probably even flatter than that, for x to the fourth. Okay, now, on the ends, here's the nice thing about this. I don't care what the x to the fourth graph, it does look somewhat like that. On the ends, was my green graph and it doing the same thing? That's called end behavior. On this end, was the green graph and the blue graph doing the same thing? That's where that x to the fourth could pay off. Yes,
What about the turning points?
I'm gonna get that right now, thank you.
Is the reason why as you go up in as you go up in exponents, that x-intercept gets flatter? Is it because the multiplicity of the x-intercept is
Beautiful, you know
also
why?
increasing?
Right quickly, oh, you guys are so good. Let me compare a few things. Let me do this. Make all these even. And let me ask you to maybe replace x by, let's try, oh boy, here goes. What should I do? Let's try, let's let x be in each one of those. Let's see if I can answer the question here. Let's try maybe a -1/2. Guys, if I let x be a -1/2 on the parabola, the x squared, just replace x by -1/2, I would have -1/2 paired up with what? 1/4. Is that true?
Yes.
If I put that same number here, -1/2, and raise it to the fourth, -1/2 times -1/2, 1/16. If I go even higher, -1/2, on this one would be like 1/64. Please tell me, Eric, you're good. Are those numbers getting closer and closer, smaller and smaller? Are they getting closer and closer to the x-axis? That's what's happening. And first, if you got that x to the 20th, it looks, as you graph it, it looks like it's almost right on top of the x-axis.
Doesn't hit it.
Oh, yeah, that's why I should make mine even flatter. He called it flatter, which is good. Really close to the x-axis, rather than mine like that. Really close to the x-axis. Okay, because those numbers are getting smaller. Okay, makes sense? Guys, any additional questions? Got this thing factored, we graphed it. Now the number of turning points, that was beautiful. Number of turning points, guys, the maximum is n minus 1. Okay, you may not get all of them, but it says expect at the max. And my degree was how much? 4. 4 minus 1 gives me 3. If I look back at my graph, I don't have 3 turning points.
It's because of the imaginary.
So thank you, I have only 1. It's down here somewhere, which we can't find. I wish we could find it before you reach math 7, but you can't. There's 1, only 1. Is it true? And so imaginary is messing this one up. Pretty good?
Yep.
Okay, I thought I'd better do that before I jump into anything else here. Now, Mana, you help us out so much here. Sometimes, even me, when I'm doing something on the board, I'll overlook and start testing, and actually I could have written down what was left over here and do some algebra on it with the grouping. And that led me right into the remaining answers without me sitting there testing and testing and testing. And sometimes you get so wrapped up with your work, you forget that. But she caught it, she said, slow down, professor, write it out, and make, yeah, it helped in this case. Yeah, Leo.
With the 3, 0, 27, 0, how would I just, would it be 3x squared plus?
Wait, what are you talking about?
3, 0, 27, yeah.
It's like the 1/3 when you got all the
Right here?
zeros 1/3.
Oh, the bottom, all the way at the bottom.
Oh, down here.
Yeah.
How I got those numbers?
No, how would I just write it out after? Like, cause wouldn't it be?
Oh, down here?
Yeah.
Oh, right here. This -2, I found it to be a 0, and this is what, raised to the 4th. So as soon as I find a 0, you know, the degree drops down 1.
Yeah.
Now you're expecting 3 zeros. Where I found 1. After you find that one, now I've already found 2 zeros of the 4, so this must be a quadratic. Written like this. 3x squared plus 0x plus 27. It drops down. So you find a 0, the degree drops down by 1.
Oh, never mind. Okay.
Does that help? Very good solve. Okay. Guys, anything else? Now, Jonathan, I need your help to close this down before we jump into another section here. Yeah. Guys, you have the handout there. And I looked at the handout before I came to class, and I know there's some other items there I have not yet quite mentioned. Hang on just a second. Oh, here it is. Here it is. Jonathan, this may not be right on there. Did I have a graph drawn at the bottom of the page? No.
Not on this, no, on a previous one.
Previous one I had a graph.
Yeah.
Already drawn for you.
Yeah.
Is that true?
Yeah.
And then I asked you to think backwards and write the function that the graph came from.
Yeah.
I provide the graph to you.
Yep.
Okay, here we go. Jonathan, if you don't mind, as I stand here and look at this, guys, I'm gonna erase this one. Here we go. Part 2. Guys, this time you're given, you don't have to sketch it. Sketch is given to you. And I hope I have on that handout a nice one. Jonathan, without me looking at it myself, describe for me where are the x-intercepts first?
Yeah. So we have, one at -2.
-2, hang on. Right here,
We have another one at 0.
0 here.
We've got another one at 1 and -4.
+1,
+1. Yeah, and then -4.
-4 on the other side.
Well, down, yeah. Oh, actually,
No,
sorry,
no, I'm
sorry.
looking for x-intercept.
Oh, sorry, not that one then. So erase that one. I think it's just, so it's just 2 and 3 after that. So the x-intercepts
Only those two?
No, and then there's two more,
Okay, what are those?
2,
Yeah, that's about two.
and then 3,
Okay, got you.
and then 3 as well.
Right here.
Yeah,
Those are my x-intercepts.
yeah,
Did I have a y-intercept?
-4, it was 1.
Is that negative on the y-axis?
It was
0, 0.
Oh, sorry, 0, 0, 0,
0, 0. That's the y-intercept.
yeah, that's what
Saw
it
that
was.
already. Now, let's see what the graph looks like. And then we gotta come up with a plan here. You're gonna be shocked what's gonna happen here. This is gonna be easy for us if the graph's, oh, what a beautiful graph. Now, here we go. The funny you get me, guys, looks like I have the graph coming down. He says this is on a previous handout. Something like that. Then it bounces back. Comes down there. It goes underneath here. It looks like it comes up, picks up 2, crosses over into something crazy, bounces back, and looks something like that. Now, let me step back and see if that's reasonable. Okay, I got it. Guys, that look pretty reasonable, what you see on the handout? Okay. And did I throw in, for some reason, an additional point that I actually labeled on that graph? What was it, out 1,
-4.
out 1, -4, so right here somewhere. And I threw that in for some reason, okay. And there's the graph. Now, the I ask you, please name the polynomial function that graph came from. Leo, just thought about you. The way it looks on the ends, like that, going up on both ends, this may have what type of a function involved? An even. It could be x squared, x to the 4th, x to the 6th, x to the 8th, if it goes like that. If one goes up and the other one goes down, it would be a odd. X cubed, x to the 5th, x to the 7th. This one says it does that on both ends. I expect an even exponent to work with. Now guys, here we go. We're trying to write this out. Please tell me, we can get at least this much done, from left to right. I got -2 as an x-intercept. Does it touch or cross? Touches. Therefore, to get that to work, x plus 2, yes, but I'm gonna put on the outside an even, to make it touch, an even exponent. I'm gonna put the smallest. If a student put 4, I couldn't count wrong. Put a 6, can't count wrong. So we'll use the smallest. As I travel further, I see another x-intercept right here at 0. Best expressed as,
X squared.
just x, just put x. Oh, by the way, does it cross over at 0?
Yeah.
Okay, so it can't be x squared.
And then also you have an odd x minus 2.
Okay, hang on now. So over here, it crosses, and he tells me to find this professor. It's x minus 2 raised to maybe the 1st,
And then, yeah, x minus 3
and
squared.
then x minus 3 on the ends. As it touches, he says you could put another 2, professor. Make it even.
And so right now it represents an x to the 6th.
Exactly. If you add those exponents up, beautiful. I got 2, 3, 4, 2 more on the end, 6. Sure enough, we're looking at an even x to the 6. Okay? And we sort of expected that, didn't we? An even?
Yeah.
Okay, now I've got the lowest numbers probably to work with here. Now, if a student says, Professor, could I have put maybe an x cubed here? Yes. Not x cubed, x to the 4th here? Yes. On this one, I shouldn't be a 1, x to the 1st, which is odd. Could I put a 3 on that one? X cubed, yes, I couldn't count wrong. Okay, but these are the lowest, that's the best. Now, oh my goodness, that's it.
Oh, you can also count the.
Oh, whoa, hang on. Let me check something first. In behavior, on both ends it's rising. Is that true? So if I try that limit as x is approaching infinity, limit as x is approaching negative infinity, I should get a positive, right?
Yeah.
And would I, with this x to the 6 coming out as my first term? Where did x to the 6 come out, guys, if I multiply all that mess together?
Yeah.
Yeah. And if I then take the limit as x is getting large on x to the 6, x is the negative limit, I think it works. Okay. Now, why, and I think Eric's trying to tell me, Professor, why, before I turn my test in, Professor, why did you throw this in here?
Oh, so you can find A.
So I can find, look at this, guys. So I can find that leading coefficient. I'd like to know where that leading coefficient is. Okay, and your textbook identifies it as, when we write this out, they like to place an A there for an unknown. Which is there's some, maybe a coefficient out front, like 3 back there. Okay, go ahead and find that if you can, what that number on this one is. Now, who has an idea, what might you do to find that particular A? Leo, go for it.
Did you say, like, P of X is 1, and then Y equals 4?
Right there,
Yeah.
they give you a point, x, y. So I can replace P of X, that's the Y, it's a negative 4, he's telling me. We got A, and replace all those X's with a 1, no problem. And we got this, and this. Now I can do the math here, if I don't mess up on math. So there's a negative 4, got A, I'm looking for A. Guys, I see a 9 here if I have no mistake. I see a 1, of course. I see a negative 1. And I guess I see 4 here, check my math. All together, got negative 4. Guys, all these numbers multiplied together, this is all arithmetic. I think it's a negative 36. I think. And divide by this, it'll be an A, negative 4A.
A is equal to 9.
There you go. And A is equal to, in this case, a positive 9. So now, with that work, now if we have no mistake, I can go back and say, oh, to make it look better, now I know that leading coefficient has a 9, like this one has a 3 back here. How's it look? Make sense?
Yeah.
Okay. Now suppose I do not give you an additional point, or somehow you just cannot use coordinates, that point was not given to you. Anyone tell me what would be best to do then?
Plug in a random point. So you can
Well, suppose, be careful with random, because that's why I like to mark mine like I've said, out 1, down 4 on this one, I think it was.
Or like plug in.
Because if you just look at the graph, you randomly think, oh, it's out 1, down 2, and it really wasn't. What's the best thing to do then, if they did not mark it really, really good for you? What's the best thing to do? Just leave this as an A. Just leave A there. Unless they really give you a specific point, I give you a point to work with. Yes?
Isn't the A is 1/9 instead of 9?
Okay, now there's 9, here we go.
1/9.
Okay, guys, I got negative 4, and I'll put a 1 in there, watch carefully here.
Isn't it
Negative 36 here,
Yeah, and
right?
then you divide the.
36, what, who gave me the 9?
Do you not divide the 4 off?
Rock, thank you, right here. Yeah, geez, Eric, 1/9. 1/9. Is that true?
Wait,
No.
wait, you have
It's- yeah,
negative 4A
You put the
equals
4A on
negative.
the wrong side, it's negative 4 is.
Oh, right
equal to
here, right, the
36A.
A here, negative 36A, talking it right here, in here. That's the A, negative 4 is by itself. Now there's 1/9. Woo! Right? How's that look? Now, if the graph is given to you, I'm sure because you can put the pieces back together and do the arithmetic and find that leading coefficient and so forth and so on. Guys, how's all that looking? Now, I'm gonna help you out a little bit. That's gonna be a little strange. I'm gonna have Jonathan read a little bit for us. With a handout to close this down so I can move on to the next section. I'm gonna give you a little method that may help you to discover what to test as a 0 early on without going through all of them, finding just by luck you find the one that works. Something else that may help you to narrow it down. Yes?
I have a quick question, aside from the amount of turning points and x-intercepts, how are we supposed to know that that's x to the sixth and not like x to the eighth? You know what I mean?
Oh, you wouldn't know.
So we just go off, like, because there's 5 turning points, we can assume that it's probably
Exactly,
x to the sixth?
exactly.
Okay.
In fact, I see, look at this here, I see a turning point here, that's 2. One down here somewhere, 3, up here, 4, and all of a sudden 5. And that would correspond exactly with my, did I have an x to the 6?
Yeah,
Yeah,
so we would just assume.
absolutely, absolutely.
So,
That's why I like for you guys to use the lowest. Yeah.
if you ever asked us to find local mins or local max.
I can't.
Well, that's where my question was, if, when the graph touches the x-axis, like at 3 and at -2,
Hang on now. You read through, oh, right here, you could tell me definitely there's a local min has a value of 0. That one for sure. You could say the local min here has a value of the y is 0. It happens at positive 3. And over there, what, -2? Is there also a local min there? 0. The ones I'm interested in, would love to show you now, but I can't, is how to find that one. Or that one. And my 2 calc students over there, they could find it easily. But you can't do it now. So there, okay? Guys, anything else? Now, Jonathan, let's sort of close this down. Please look at the handout. That handout's so valuable. Is there something called intermediate value property or theorem
Yeah.
listed? Oh my goodness. Would you read that, and this is like you lifting the textbook up, and you reading on your own, you don't have Ramsey or the TAs, my helpers, you don't have anyone to help you, you're on your own, and you've got to read the intermediate value theorem of property, and then try to make some sense of it to be ready for a question about it. Read that to us.
So, intermediate value theorem, it says, let f denote a polynomial function if a is less than b, and if f of a and f of b are of opposite sign, there is at least one real zero of f between a and b.
Okay. Now you ready to have a quiz on that? That's what I should do one day, so you would appreciate professors more. I should just write down the math statement, and I'll say I took it directly from your textbook. Just write the statement down, and there's your quiz. They have a few questions about it, and see if you guys could understand without someone's help. Yeah, that was my problem in grad school. I told you many times, that was my problem. Undergraduate, I had professors who told, like, I just tell you guys how to do these things. I had professors like that in undergrad. I got to grad, that professor ran to his or her office and locked the door. And once you revolve it, they were doing research. They were doing research at the university. They didn't have time, they didn't really enjoy teaching, but they had to teach to be hired. They were going more involved in research. Can you imagine that? Present to you today and say, here's your quiz. John read it to me, but what on earth? John, read that one more time, and I'll get some input from students.
Yeah, so, let f denote a polynomial function if a is less than b.
Okay, hang on, I'm doing a little visual here, see, maybe, can I describe it visually? Okay, talking about A and B, you said A is less than B.
Yeah, if a is less than b.
Okay, we put A on this side and B on this side. That makes A less than B.
And then it says, and if f of a and f of b are opposite signs.
Oh, just opposite signs, so that says when I get to, for example, A, to have opposite signs, I may want to go above the x-axis at A, that's a possibility, place it here. And all of a sudden you say, well, hold on, professor, if you go above there, it says opposite, you
Yeah.
reach the other end, they gotta go down here somewhere, below. That's what they mean by f of A and f of B are opposite signs. One's above, one's below. Tell us some more.
And now it says, there is at least one real zero of f between a and b.
Now, this is supposed to be a polynomial function, Okay, so the whole graph is supposed to be, now we'll just show you the slice of the graph we need, but it's supposed to be a polynomial function. And you say, Professor, I know I gotta connect these 2 points. It might go like this with a curve, and maybe just go up like that, pick that up, that. So I'm gonna make it look something like this, guys, more like a polynomial function. It may go up, pick that up, come on down. Now I gotta come down to pick up the next point. It may do something like that, who knows, it may do that, and then back up. Make it look more like a continuous graph, nice and smooth, polynomial function. Please tell me, did I, as I connect the point, did I at least cross the x-axis at least once?
Yes.
We're not connected. Is this x-intercept, in this case, acting as one of the zeros? Now, you say, Professor, could you have connected it a little differently? The points there. Well, guys, I could have connected like this, up here, pick this up, and then come down. Something crazy could have been happening. I could come down like this, then back up, then down, and something like that. I could have crossed between A and B. Could I cross more than once?
Yes.
It all depends on the shape. So it says at least once. How did it end? At least one?
Yeah, it said that there was at least one rule zero.
You're going to do at least one. Now, can someone tell me? Be clever, I got a clever class in here. Can someone tell me what would have been a good way for you to have maybe discover that maybe you should test 1/3, Professor? Of all those choices, Professor, and all these combinations, that maybe I could test 1/3 based on this intermediate value property.
Test in between -2 and 1.
You can test in between, intermediate, in between. I notice it didn't say you really have to use one of the zeros. We have it.
-1 and 1.
Good. In fact, I think it's going to work like this. Suppose on the side here, I ask you to find f of 0 on this one, b of 0. And then all of a sudden jump up to 1. Know what guys does 1/3 fall between 0 and 1? Okay? And since I've already found 1/3 does work, I guarantee you when I calculate those, you're going to see a sign change. Which if I had known ahead of time, that would then have eliminated some of these possibilities. Guys, p of 0, I take 5, I find p of 0 back on the black, I think I end up with -18. If I try p of 1, it's not really too bad. I'll think I tested 1 here. P of 1, I see 3 plus 5 is 8, plus 25 is 33. Oh my goodness, that's 78 minus 18, I think it's 60. Is there a sign change between those two? Guess what this intermediate value property guarantees? You have at least one answer that you're searching for over here on this polynomial function, caught between 0 and 1. And in fact, it was 1/3. That says at least one. Sometimes you get more than one. Caught between 0 and 1 because of that sign change.
So if we get this, we would want to test 1/3 and 2/3.
You could, but you could start just testing any way you wish. And sometimes I'll let you know which numbers to test. And if you see a sign change, stop right there and say, oh my goodness, I see a sign change, and therefore I'm going to search for in these combinations. You guys just do this. Let's list all the possibilities. Look at this. That would fall between 0 and 1. I know 1/3 works. Other possibilities would be like, oh my goodness. Is 1/3 the only possibility? No, 2/3. Okay, I got 1/3. 2/3. That falls between 0 and 1.
That's it.
Look at that. All right, that's just 2. And 1/3, sure enough, was one of the zeros. Someone tell me this. Before I take questions here. Since we have the zeros listed up here, -2 works. Give me two numbers that -2 is caught between, and see if I get a sign change there.
0 and -4.
Well, you can widen it out if you wish. I'd narrow it down as close as I could.
-3 and 0.
-3, let's test -3.
Or there's -3 and -1.
I got you. -1?
Yeah. Make it easier on yourself.
And by the way, guys, there's -2 caught between -1, -3. Okay, that should be a sign change. Let me see if there is. Maybe I have to crunch out -3. Did I test -3 somewhere along the line? Leo, that was your favorite number, or your favorite number was 3?
No, he
though.
tested +3.
Did it come out to be positive? And there it comes.
That was +3, I don't remember.
Oh, +3. Okay, I did not test -3. Okay, let me do this. I don't want to do a direct substitution on -3. Let's do it by synthetic. What a good lesson here. You can do it by direct. That's right, -3 by synthetic. Much faster. Okay, 0, 3, -9. Is that -4? 12, is that 37? Don't make a mistake. 21, help me out here, is that -111? Real quickly. Add those up, if I'm correct, that's a -111, subtract 45, someone help me. Is that 66? Is it 66? I'm still quickly. And then that times that is a positive 3 times 66, is that 198?
Yes.
I did quickly. Jeez, okay, hang on. Well, what it comes down to, is this gonna be like, I know it's gonna be what, 180? If my arithmetic's correct. Is that true, guys? Is that positive? Right, so that's positive. Now suppose I test -1. A little bit easier. We'll do it by synthetic rather than direct. Do not let me mess up here, this is cute. Here we go, -1, 0, 3, -3, 2, -2, 23, -23, what can we mess up here? 22, is it? -22, -40. If I made a mistake. Chris, is that right? So I got -40, so -3, I got 180 positive, and -40 for this one. Did the sign change? Therefore, you would expect at least one answer caught between -1 and -3, and we found it, -2.
Oh, that's interesting.
Isn't it? I love it, when it works. When it works, you say, oh, boy, when it doesn't work, Professor, what happens? Well, you see me again in the spring. Yeah, so I may give you a hint for the next quiz, or the next, especially the next exam. I may give you a hint on the side there, use the intermediate value property, and I'll tell you which numbers to test. And you might see a sign change, and therefore that may help you to select what you'd like to test. Yeah.
Well, the best, like, say we're just given the problem, it didn't give us a hint.
Exactly.
In general, it seems like these smaller numbers and polynomials are working, so like, would it just be best to find a small number and then just set like right outside of both of them, if that makes sense, how we did with -3 and
Yeah, again, when you start that testing, you can, oh boy, you can test in many different ways. That's why I'm gonna probably on the quiz or test, I'll give you numbers I want you to test.
Because -3 and -1 would also, oh, never mind.
Yeah, and like, Jonathan told me, he wanted to test -4 and -1. And -2 is caught between, that's intermediate, right?
Yeah.
He wanted to, and I bet there's a sign change there. But I think I'd get as close as I could. Okay? That's where I'll give you the numbers to test myself probably. Leo?
Let's say you did give us the numbers, but we just look at the bank of P, like of P and Q, and just start testing the numbers, the smaller numbers out of that.
And you could, there's all different ways here, you could.
Would it be smart to like start with like a larger interval, like maybe like -3 to 3, and then just keep working?
Well,
your way down?
you're not, beautiful. If I went from -4 to, like you want me, -4 over to a -1.
Yeah.
The -2 is caught between, but there's some other numbers also caught between that may work. So if you brought this thing out, you might be lucky to pick up more than one of the zeros. You may end up with 2, because I think this theorem says at least 1. Was it, is that the way it's phrased, at least 1?
Yeah.
So that says there could be others.
The equivalent.
That might be better, brought it out. Okay, guys, all this making sense, so? Yeah, I love polynomial functions. Anna, Park, not Reverend Park, I had Park in math 2. He loved polynomial functions. And then in chapter 3, they change it. They go to a different function. He said, oh no, we're not finally feeling at ease with this one, it makes so much sense, and the graphs are all nice and smooth, and everything's great, and I love it, Professor. What's gonna happen to end chapter 3? And I brought in a handout to help us. To end chapter 3, they're gonna say, now jump into another type of function which is not well behaved, like these, called rational functions. When I start these, get ready, in chapter 3. These are the ones where there could be holes on the graph. There could be actually a graph, and all of a sudden you've got this graph going on for you, and all of a sudden, for some reason, are you kidding? There's a hole. And also they use a word here, they are discontinuous. They're not smooth and all connected like these beautiful polynomial functions. You wish you were back on these shortly. Because these coming up, when I finally get to them, I'm gonna watch you. When I finally get to them, guys, I'll show you something going on here. You could have a piece doing this, and all of a sudden it's not connected to the other piece. The other piece is way down here. They're disconnected.
1 over x.
They're called rational functions. And the word is they are discontinuous, so not connected. They're discontinuous, they've got certain parts that you gotta do. This one has 2 parts, could be 3 parts, could be 4, so it gets crazy. So guys, let me just introduce real quickly before that break comes up. I love this though. I love the conversation we had about this. Now, anything at all, check that handout though, was this, whoa, I did think one more thing, we'll take this break. Was there anything else that I'm leaving out? Jonathan?
There was just an example after the intermediate value theorem, but that was
just an example.
Yeah, and then it goes to complex zeros.
Okay, now that's where I need to go. Go down, what's it asking at the bottom of the page, something about complex zeros, read that to us.
Yeah, so section 3.4 complex zeros, it says fundamental theorem of algebra, and then it says every complex polynomial function f of degree n greater than or equal to 1 has at least one complex zero.
We would think that, but they call it fundamental theorem. We would think that. Do you have anything else in there?
Just an example after that, and then conjugate pairs theorem.
Ooh, conjugate pairs theorem, I thought it was, leave that out there, be careful, read that to me.
So conjugate pairs theorem says, suppose f is a polynomial function whose coefficients are real numbers. If r equals a plus b I is a zero of f, the complex conjugate r equals a minus bi is also a zero of f.
Mathematicians are crazy. Okay, a plus bi and a minus bi. So if you get something like 2 plus 3i as one of the zeros, automatically, you don't have to test anymore, 2 minus 3i, it's also a 0. They come in pairs. So, in fact, one I did here on the board, I think, did we not end up with a plus and minus I earlier?
Yeah.
They come in pairs.
Because they're radicals, right?
Exactly.
They're products of a radical.
So, a plus bi, a minus bi, so if you end up something like that, they come in pairs, okay? Did I have an example down there?
Yeah, and then it says find a polynomial function with real coefficients.
Okay, now here we go, this way we'll close it down, here we go. Hang on just a second. Quickly, guys, now I'm making this up crazy. Let's say that was your function. Oh, give X. Trinomial. And I asked you to find the zeros. You said, my goodness, professor, it's a quadratic. That was the last test. I'm gonna use quadratic formula to find the zero. I'm not gonna go through that P over Q business here. X is equal to, by quadratic, -1 plus minus, don't be missing here. 1 b squared minus 4 times a times c. I think you get aq all over 2. Now I did that quickly. In the quadratic formula, b squared minus 4 times a times c. I think you're going to end up with, and watch for mistakes, because I wrote it so quickly, -1 plus minus, is that square root of -7?
Yeah.
The best I can say there is I radical 7. Still over 2. Is that true? Okay, I can't break 7 down, so I'm just leave it. Now if I separate them, here goes the pairs. They call it conjugate pairs. If I separate them, one answer looks like this. The other one separated, looks like this. I think he said something like A plus BI, automatically the other one has to be A minus BI. Is that sort of what's happening here? They come in pairs. And you guys probably recognize they do that, you're just trying to solve equations back on quadratic. They come in pairs. Now, read that last thing to me before the break.
The example or?
Yeah, the example says find the polynomial function, I think.
Yep, so find the polynomial function with real coefficients having the given degree and zeros.
Okay, first, what was the given degree?
So the degree was 4.
Okay, 4, let's tell me more.
And then the zeros are 3, multiplicity 2,
I love it, okay?
and comma, negative I.
Oh, should be some harder. Okay, that's too easy. Did I have one after that also?
Yeah.
Okay, hang on, I'll do both. Guys, they bring in zeros to you. You know what's fine. They want to know what is a possible polynomial function that would give those zeros. I said, Professor, it's no problem. And by the way, on this one, Jonathan, that's all they gave us.
Yep.
Okay, now this is P of X is equal to, I am going to use an A out front. You may not be able to find it in this case. 3 multiplicity of 2, guys, please tell me, is that X minus 3 squared? Would that give 3 twice? Multiplicity of 2. Then they mentioned I, but they didn't give me the other one.
Yeah.
And why?
Would it
Because
be
they are
X?
assuming we know the not the intermediate value theorem, the conjugate pairs, they come in pairs.
So it'd be X squared plus.
Yeah, well, automatically, he can give it to me. Can I say, automatically, does I also work? If they come in pairs. And sometimes they will not give you both, just assume you'll find it. And if I write this out, I've got X plus I, and also X minus I. Or, if you wish, multiply these two together, I think we'll end up with X squared minus I squared if you use FOIL. Is that true? Now, a student was asking me, I think in the 11:30 session, Professor, I know I is this. If you know what I is, which is square root of -1, definitely you know what this is, if you need it. What's I squared? What happens if you square that square root?
It's just negative.
The square root drops off and leaves you what? -1, therefore I can replace that by -1. That's replacement. If I'd like to go further and not have an I, so this is X squared subtract -1, I can say it's X squared plus 1. So guys, my answer right now is A out front, I don't know what the leading coefficient is, X minus 3 squared, and I'm gonna write the last part as X squared plus 1, and let that serve as my function. Just closing out the section. Jonathan, please tell us, and we'll take a well-deserved break here. What's the last one?
So the last one is degree 5.
Hang on, degree 5.
Zeros are 1 multiplicity 3,
0, 1 multiplicity of 3.
comma, 1 plus I.
Love it.
And then it says and
Oh, and what?
and P of 2
Is equal to,
-6.
beautiful. We'll work this out, see what happens. Oh, we wonder why they gave me P of 2 is equal to -6. What would that allow me to do that I could not do on the last one? I can find the A. I can find that leading coefficient. You guys put all this together. Here goes degree 5 with those. P of X is equal to, let's put an A in here. I'm missing right now. And he gave me a 1 multiplicity of 3. Would that be written as X minus 1 cubed?
Yeah.
Now, he gave me 1 plus I. This is where I have to be very careful. Anyone tell me a factor that you are guaranteed when you solve it, you get that? That's why I placed that one. I think it was the last example on there. That's why I placed it at the end. Anyone give me a factor that guarantees you set it equal to 0 and get the x by itself, solve for x, you get 1 plus I. Leo, go for it.
Would it be, negative?
All right, what about the next in there?
Yeah, negative x.
No, x. Now what's it gonna take for me to place it with that
Well, you
x?
do need, if you're getting I, you need a square.
No, let's leave the square out. No square. Now, let me show you again what I'm after. If I split this up right now at this point, everyone would say, Professor, if you split that up, the first one, of course you get 1. And that's what he said.
It'd be x minus 1 minus I.
Oh, look at that.
And then,
You know, am I looking strange? Now, let me make sure Eric's correct. X minus 1 minus I, if you take that and set it equal to 0 for a check, and solve for x, in other words, move everything over, please tell me, if you move terms over, do you get 1 plus I? Did they say 1 plus I was a 0? Would that factor set equal to 0 that he gave me, if you solve it, does that give me 1 plus I? Now though, that's not enough. This conjugate pair says they come in pairs. So that means there's one that they left out. Now I've got to be careful with, if 1 plus I works, what else works?
1 minus.
1 minus I. Oh, aren't we having fun? A plus BI, A minus BI. Now I got to write another factor. Now be careful, real careful. Let me close down here. Does anyone be clever and tell me what would the next one look like, so when you solve it, you get that?
X plus 1, or x minus 1 plus I.
There you go. And at this point, that's what I have. At this point. I'm gonna close down and shoot short. At this point, that's what I have. You guys agree so far? Right here at the end, I know it's happened right at the very end where you get a little tired here. Remove this. Remove it. Now guys, we do this for a check. I've already checked this one. If I take this that was given to me, set equals 0 and solve, yes, I get the 1. That's a multiple answer, 3. If I take this one that Eric gave me right here, he said, Professor, write the next one like that. I will, and we'll test it. Set equals 0, solve it, move the 1 over, move the I over, I get that. And then since they come in pairs, if 1 plus I, then automatically what? 1 minus I. I think they call it what? A plus BI and A minus BI. So I'll go to the next one automatically, and that factor, that right there, if you solve it, will give you that one. Is that true? I got them all. But there's a catch before I take a break. They also gave me the P of, what was that, P of 2? Yeah, that's P of 2. Is equal to a negative 6. What does that tell me I'm supposed to do now with that mess up there?
Negative 6 is equal to A times.
Negative 6 is equal to A times, we'll replace all those X's by, or 2. Is that true? Now, I'm going to do it, and then I'm going to have send you a suggestion. Here we go. Eric says, Professor, from there, do this. P of 2 is equal to 6, that means negative 6 is equal to A, I'm looking for A. In place of all those X's, please put 2. That's 2 subtract 1 cubed. 2 subtract 1 minus I, oh my goodness. And the green, 2 minus 1 plus I. Woo! Did I do that correctly?
Yeah.
Okay, now they're saying if you're clever and we're clever, you should be able now to do some crunching and find A. Let's see if I can. Negative 6, A. Guys, inside here is easy, that's 1 cubed, that's 1. What's not so, oh well, not too bad. Here, I'm gonna clean it up, 2 subtract 1 is 1, so let's call that that. And now here, 1 plus I. Let's put my numbers together, 2 minus 1. Is that true? If I go further, I got negative 6. It's equal to A, got a 1. Guys, now if I multiply these two together, now I'd like to get rid of those I's, not good. Please tell me if you multiply those two together, some of you guys use something called FOIL. Is that 1 minus I squared?
Yeah, which is negative 1.
There you go. So I got negative 6 A, one, and Eric tells me one minus I squared, professor, is one minus negative one is I squared. I think we discussed that earlier. Let's remember, replace I squared with a negative one. And therefore we get negative six, geez. A, one, is turned into what, a two? Now watch my arithmetic here. I'm going to divide by two, is that negative three? Yeah. Negative three is equal to A. If there's no mistake. Jonathan, final answer? Let's go back and replace this by negative three. And I'll accept the answer.
Professor, could you show us how to rewrite those two
I
as
am.
without terms of
I am. But right now, we're good. Now, if on the test quiz, I'll say, okay, you did beautiful work, I like that, but now can you express it and have no I's in your final answer? Keep the three out front, is it three or negative three? Negative three? Yeah. Keep the negative three out front, leave that alone. Leave the x minus one cubed alone, but for some reason I don't like the I's. I guess multiply it out. Now, look at this being clever. Guys, I want to multiply these two together. And there's no way you and I before the break we're going to do this. I'm not going to do it. Middle school kids across the street would do it this way. They would use the distribute property. They would distribute x on each one of these in the green. Then they go back and distribute the negative one on each one of those in the green. Distribute negative I on each one in the green and have a mess, which is good. It'll work. Gotta be patient and combine like terms. No. Easy way. Let's do this. I better get my. I won't use. I thought I had a red marker here, but I gotta close this down nicely here. I'm gonna multiply those two together. Anna, Mark, I'm gonna multiply these two together so nicely. Without that middle school, I'm gonna group. And think of it first like that. And now, from middle school, that's what it looks like, this form. A subtract B times A plus B.
of difference of squares.
That's what it reminds me of, the form. And I know that from middle school is A squared minus B squared. Is that true? Is that true? Now, if I notice A squared minus B squared, what's representing A here, the way I group? X minus one. So this is X minus one squared. And it says subtract by a difference of squares here. What's acting as the B? Is that I? Is I acting as the B? Yes or no?
Yes.
And now just multiply that out, and the I is going to be gone. What's what happens? If I expand this out, you get x squared. Subtract 2x plus 1, that's algebra. Down here, I know minus, and I know I squared is a negative 1. I'll put that in. The I's gone. And therefore, x squared subtract 2x. Guys, I think we're going to end up with down here what? 1 plus 1?
2.
2. Therefore, you may see in the textbook when you check your answers, they may not have the I's up here remaining. They may say, no, rewrite it as this. We've got negative 3, x minus 1 cubed, and then they have on the end, where was it? Where am I? I'm moving it here. Was it x squared minus 2x plus 2?
Yeah.
Here. And Jonathan looks in the back of the textbook and says, Professor, where on earth did that the red come from? I had my answer like this. They just multiplied it out. I got rid of the I's. Eric, is that what you were concerned about?
Yes, exactly.
Yeah, just multiply it out. And the I's are gone. How's that look? Much better. I don't like those I's in there. Okay, but do not insist you get rid of them. Leave them. I'll be correct. Woo. 15-minute break. And we got a little short quiz tonight. Are you guys, I'm looking at my clock here. Now, you guys know by now, I'll come outside the door. You guys are just out there doing nothing. In 15 minutes, I'll let you know it's time to come back in. Yeah, I asked a couple of my students who always came in late, I asked them, did you go to the beach? Where'd you go? About 15 minutes. Went to the beach and run back? Jeez. Okay, so I'll be at the door. Okay, I think 15 minutes.